In the next two videos, I will tell you how to compare two population means when we've got two small samples and when the number of observations is lower than 30. So to construct a confidence interval, similar to the case of a large sample, we need the difference between two sample means, plus minus, and as usual, instead of using z-score, we will use t-statistic at the level of significance alpha over 2. Multiplied by the square root out of s squared p multiplied by 1 divided by n1, which is sample size 1, plus 1 divided by n2, which is sample size 2. And to get the value of sp squared, we will use this formula. So in the numerator, we have n1 minus 1, so sample size 1 minus 1, multiplied by the the variance of the first sample, plus n2 minus 1, so sample size 2 minus 1, multiplied by the variance of the second sample, and in the denominator we've got n1 sample size 1 plus n2 sample size 2 minus 2. As always, alpha represents the significance level of 1, 5, or 10%. And as for the critical t-value, in addition to knowing the level of significance, we also need to know degrees of freedom. And in this case, the degrees of freedom will be calculated as n1 plus n2, so two sample sizes minus 2. And there is a small note for you, so when n1 is equal to n2, sp squared reduces to the following formula, so sample variance 1 plus sample variance 2 divided by 2. We can also do hypothesis testing for the difference between two population means when we have two small samples. To do that, we will estimate the t-statistic, which will be equal to the difference between two sample means minus d0, where d0 is the hypothetical value of the difference between two population means. And for testing equal population means, we will set d0 equal to 0. And in the denominator, we've got the square root out of sp squared multiplied by the sum of 1 over n1 and 1 over n2. And here is a quick summary of three types of tests and the rejection rules. So the null hypothesis is the same as in case of large samples, that the true difference in population means is equal to d0. And as for the alternative hypothesis, it is also identical to the case of large samples. In case of the negative tail test, the difference is lower than d0. In case of the positive tail test, the difference between two population means is higher than d0. And in case of the two-tail test, the difference between two population means is not equal to d0. And the rejection rule is very similar to large sample case. So we reject the null in case of the negative tail test when the estimated t-value is lower than the negative critical value of t at the level of significance alpha. In case of the positive tail test, we reject the null hypothesis when the estimated t-value is higher than the critical t-value at the significance level alpha. And for the two-tail test, the null hypothesis is rejected when the t-value in the absolute terms is higher than the critical value of t at level alpha divided by 2.